Okay. Indexed optics are an adaptable Swiss Army knife. They help to address a lot of practical problems you'll come across when using optics in everyday life. Since optics are already a Swiss Army knife all on their own, index optics are like a Swiss Army knife within a Swiss Army knife. I feel like that would actually get awkward, but that's fine. Basic idea of indexed optics is that they allow you to accumulate information about your current focus as you dive deeper into the optics path. Okay, that's kind of interesting. So it's like if you have a super nested structure, you can use pieces of it or something. Um, for instance, traversing a list will provide the list index maps. Provide the list index. Maps provide the key of the focused value as an index. Tree traversal will provide the location of the current element within the tree, etc. Good news is almost all of the optics and combinators you've already worked with seamlessly, learned work seamlessly with indices. Index optics compose just fine with index and non-index optics alike. There are a few gotchas and tricks with that, but I'll introduce them as we come up, or as they come up. Um, Start getting an intuition for indices and how they work. Let's learn a new combinator. I traversed. So index traversed, I guess. And you have an indexed traversal. I traversed comes from a new. Oh, it finally looks like I'm online now. So hello. You're actually. I think there's one person watching. Hello. When implementing the type class, you need to specify the types of the indexes and the values for the container. This should remind you of implementing the IXed. I think I called this IXed before, but it's probably indexed and at type classes. We'll cover that later on. The iTraversed traversal behaves identically to traversed, but it keeps track of the current index as it does so. We can use this in place of traversed without noticing any difference. Wonderful. So the way we typically run this one is we keep a REPL open, and then we just start like labeling these as letters, and we just kind of go up as we get through the chapter. The chapters have been getting a little sort of denser and shorter, so we probably won't get very far here. So anyway, control lens a equals to list of I traverse uh summer winter winter spring. How was your Christmas if you are celebrating? Oh, you don't have to say anything actually. You don't want to, but it's curious. Okay. So I nothing's happening. This is essentially just the um this is just the uh, identity operation more or less. Um Too much quiche. That sounds delicious. I should have made quiche. That would have been a great idea. Um I don't know that I've ever made a quiche. I usually make like a frittata or something like that. Quiche is a little bit harder, I suppose. So I think that this is equivalent to list of. So I just want to make sure I'm remembering that correctly. Um, Maybe it's not exactly like that, but I don't remember. What is this complaining about? I don't exactly remember how this works, but I thought that that's what to list of was, but maybe that's not correct. Now I want to look that up. Let's go over here. To list of control lens combinators. This is probably the right one. And there's a lot of these. Night Sky. It's a cool name. I don't know that I recognize that name though. So hopefully, if this is, yeah, this is right. So what did I do wrong? So to list of takes I traversed. Oh, it's supposed to be the other way, I guess. I guess this goes here. Okay, I just had it backwards. Sometimes I forget what the order of operations. So anyway, I wanted to remember what that was, so I'm glad we looked it up. So there's that. The magic happens when we start using indexed actions. So there's I to list of. Presume that that doesn't have a. Oh, it does have an operator at. Oh, that's kind of useful. So we're gonna have B. We'll just use this same thing, I guess. And then I traverse, I guess. So does this actually look like it contains the indices? Oh, nice. Okay, so um, that's pretty sweet. I like the at to indicate indexed. I don't know why, but oh wait, no. We would use this for like no, we don't use this for indexing like a list or something. Not that that would be the thing you should do anyway, but trying to think of where we use at in other places, but I can't come up with anything. Um, so there we go. It's very important to note that it's the action which adds the index to the result. The index isn't part of the focus of any optics in the path. We can compose optics together without worrying about passing the index manually. Actions with indexed variants often also have infix operators. Try adding at in the middle of your favorite operators to get the indexed action. Okay, so there's I to list of, I over, I traverse of, I set, I view. Cool. I assume there's probably also the question mark one as well. So that's, you can see how that would be useful. Every indexed action accepts an indexed optics. For example, I to list of uses an indexed fold. There are indexed versions of lens, traversal, folds, getter, setter, etc. The lens library doesn't provide index versions of prisms or ISOs. They're relatively uncommon, but you could write type aliases for them if you wanted to. Neat. Let's see how iTraverse behaved for some different container types which implement traversable with index. Sure. So we'll call this agenda. Hey, type rat, how's it going? How to translate that into Latin? Is that a joke that I don't understand? I think it's a joke I don't understand. Oh wait, no, we don't want to do it like this. What we should do is do uh, is there some, I'm totally lost. You've oh, is the joke in the text and it's that? Or I'm anyway. Okay. I'm just gonna keep going. All right, so we got Monday. Assuming gender in 2020, am I right? That's a classic. To be fair, I did know that, but I don't think you would know that. It's okay. I'm probably fine. I don't think she's offended. Maybe she's offended, but I hope not. I do not see the. Okay, I was kind of expecting that to be there, but let's just write map and see if it's smarter. Yeah, wonderful. It's not smart enough, unfortunately. Maybe I don't have containers actually. Um, qualified not control. Data map as m, and then we'll also get map. I don't actually know if we'll need that, but we can do that. Why is that redundant? Oh, it's redundant because I'm not using it yet. But we may need it later, so we'll just leave it here. All right, so we can do agenda. indexed view, sorry, indexed to list of I traversed. Um, all right, so this is a to list of. Wait, what? Why don't we see the? Oh, it probably iterates over the keys. It just appends the keys, so essentially nothing changes in this case. Kind of looks the same because the. And if we do this with just traversed, oh wait, like that, we just get okay the values. Okay, cool. Can we? Does this still type check? And what happens if we do this? Interesting. So I traversed versus traversed behave slightly differently for a map. That's kind of interesting. Okay. Um. So actually, I kind of want to write that down. So I traversed will add keys as indexes, whereas traversed will add integer. They're probably ints. Int indices. That's kind of an interesting behavior that I wasn't expecting. So there's that. Um, so true value to list of I traversed. So my guess is it's just going to return this in a list based on this. And then if we change this to traversed, it would give us 0 and value. So let's just quickly test that. D, true value, remove the I, 0 value. Perfect. Okay. Intuition. Build intuition. Okay. So maybe we won't need this. So let's just get rid of it. It's fine. Um, data tree as T E. Let T node T node left in to list of I traversed. I mean, I don't even know why I'm writing this down because I feel like the behavior is going to be obvious. Whoops, I meant to do that. I think the behavior is going to be obvious. We're just going to pair up. Um, oh, wait, no. Maybe the behavior is not obvious here. Maybe we're just going to pair up top with numbers, whether we use I traverse or traversed. That would be my intuition. Oh, interesting. So why do we need a list here? Weird. That's not what I was expecting at all. If we just used traversed, do we get like regular old numbers? Yes, we do. So that's kind of interesting. I don't immediately see why we need lists of things there. But maybe it becomes more obvious if I embed another example. Left prime. Oh, okay. It's like the path to get there. So if you went, you like 0, 0 means go left, go left. That makes more sense. Okay. It's the path. So I traversed will yield list of 0 or 1 indicating path. Traversed yields like label. I don't know. Something like this is probably fine. So that's kind of interesting. We already talked about this. This is weird. Okay, so index composition. Indexes can compose alongside the optics, but unfortunately it can be a bit less intuitive. By default, the index of a path will be the index of the last optic in the path. The index of a path will be the last of the the index of the last optic in the path. Oh, okay, okay. So Monday is the 0th index. No, that doesn't make sense. Because it goes 0, 1, 0, 1. That's kind of weird. Um, Maybe that makes sense. There's probably some law that defines that behavior. I don't know what I want to write down for that one. Okay, if we end the path with a non-indexed optic like traverse, we'll get an error. A pretty nasty error. Ew, agreed. Even after formatting it nicely, it's still impossible to read. When used with indexed actions, make sure that your path has the type you expect and ends with an indexed optic. So when composing optics, the index of the whole path, the index of the last optic, and only if it's an indexed optic. So what if we want to look at an index provided earlier in the path? For example, what if we want our list of activities paired with their day of the week instead? For that, we need to rethink how we're composing our optic. So there's several index-aware composition operators. We'll call this left index, right index. This is already how dot behaves. Um, Both. That's kind of fun. Let's use left. Okay. So EF. I don't think I should do that. We already have agenda. Let's just call this A. Whatever. Let's call it derp. We're not going to use derp anywhere else. Whoa, hey, 6 viewers. How's it going? Merry Christmas if you're celebrating. Otherwise, just happy holidays. Are we ready for 2020 to be over? I would guess so. Okay, so anyway, let's grab this and we'll clean this up a little bit so that we can format it. Should be good enough. Why is this not good enough? Probably because we need like in wrong thing. There we go. And then we will derp index to list of I traversed, use left index and traverse a second time. Okay, we're gonna have to play around with this a little bit because I'm not feeling super confident about what this is going to do. But I think that it's just going to give us shopping, yoga, brunch, and food coma with monotonically increasing integers next to them. Let's see if that's correct. Oh, wait. That is. Oh, okay, okay. Wait. Let's see here. So this, okay, right. This I traversed uses Monday as the key, and then we have a list. Hang on, let's do this again. So let's start here. So this gives us 0101, which is like 0, or sorry, it's indexing this list with its traversal because we focused on shopping and yoga, so it's as if it's like a list. And so they get 0 1, and then we focus on this one, which is like 0 and 1, and that's why this is 0 1 0 1. But what we're saying here is that we don't want to forget the key of the first I traversed, and we want to ignore the key of the second one, I guess. And so this will give us what we had before, which is this. If we do that, then I suppose we're going to have 0 Monday, 1 Monday. Not exactly sure what order they're going to be in. It's probably going to be Monday and then 0. That would be my initial feeling. Yeah. So that, I think that makes sense because it's like, the one on the left should be the furthest left. Okay. So I don't know what notes to write here. Let's see here. So using dot will yield 0101 because focus is two lists, or sort of is a list over two keys or something. We'll use the index on the left. In other words, the keys. We'll combine the keys and numeric indices from this. It's not what I wanted to do, but that's fine. I think those are decent notes, actually. Okay. And yeah, that's what we just did a second ago. We wrote that. So let's see. This is a ridiculous thing to do, but it'll show you how the indexes nest. We'll use an index traversal over the characters of each activity name. Combined, I traversed, combined. So we're gonna get like I don't know how to say this, like right weighted nesting. If we added another one, there would be a parenthesis right here, basically. Okay. Weird, but cool. Custom index composition. If we want to be a bit smarter about how indices are combined, we can use iCompose. Type signature is a bit messy. The gist is that iCompose composes any two indexed objects into a new indexed object by combining the indices together with a user-defined function. Okay, that makes sense. So it's kind of like uh, concat map or something. That's what I'm trying to think of. Something like that. Okay, so as an example, we could use iCompose to append the list index of the week, day of the week, as a string. We have a string and an integer, and we'll just combine them with a colon. 0 month. Weird thing to do, but sure. This can be a bit clunky. So if it's something you'll be using often, it's typically nice to define a new operator. Let's define a custom optics composition operator that'll automatically append string indices with a comma separator. Okay, that makes sense. Oh. That's kind of fun. Okay, so let me put this here. Should just copy and paste. Okay, and then let's and paste this. Okay. So combine string combined. What is this going to be? It's going to combined string indexes together. In other words, both keys from above, or sort of outer with inner key for population map. Okay. So what letter are we on? E. We're gonna write population map to list of I traversed. That compiles and does the thing we wanted to do. Cool. Pretty sweet, actually. The hardest part about writing these custom operators is figuring out their type. Optics have complex types, which means inference can sometimes be ambiguous. When defining a new composition operator like this, you can follow this template. So index type A, index type B, combined type B. Couldn't you write like a generic one of these for monoids? Like anything that's a monoid, you would just iCompose mapend? Is that not a thing? Let's see if this works. I'm very curious now. So let's do we're gonna call it dot and this. Okay. And then basically what we're going to say is this is going to be not A. Let's use, I don't know, C. R for result. And then we're going to say monoid R. And then I compose. That's kind of fun. So for anything that's a monoid, this would work. And string is a monoid, so we could put at. No. Very sad. for all r. Let's see if this error is as terrible. Okay, so we want this to be string. Okay. So we can't have rankin types. We need type applications. Skybro, 1 year of subscriptions. Wow. Just wow. Thanks so much, man. Like really, that's awesome. Super, super nice of you. Didn't we just turn this on? Type applications? Maybe we can't actually put these things together. Let's call this mcompose. How's your day going, Skybro? No, it's unhappy. Um, I don't know. Kind of unfortunate. I was hoping that we could like get that to work because it's kind of cool, but I'm not that surprised that the types are having a rough time. Visited parents, got home, took a nap, doing a bit of nice, very good. We, my girlfriend and I, baked cookies all day, pretty much. Met with my family. We didn't go back to my parents' house, but we did like a video call, and so that was nice. And now I'm trying to catch up on streams. We want to finish. I really want to finish this book by the end of the year. Um, so that's kind of the goal right now. So I can start something new. That's the goal. All right. So exercise, but all in all, a good day. Yeah. Nice. Very good for math, right? Straight. Yeah. Nice. That's great. I'm glad that you decided to do that, and are going for it. If there's anything I can do to help, let me know. I don't know if there is. We're on H. So I'm gonna do this, and we're gonna say this. So basically, the goal of these exercises is you're obviously filling in the blank to get a particular answer. So, excuse me. In this case, this is just the normal indexed to list of. I'm pretty sure. No, that's fine. I mean, I probably won't answer every day, but you're welcome to bother me every day about it. Yeah, so that works perfectly. Easy. I index to list of underscore. The answer is okay. So we have a tuple of these. So it's going to be each. Is there an I each? I don't think so. I traversed, probably. I bet there's probably an I each, but I don't think that there is not. Okay, so each, if we have like any number of n tuple, for example, we can use each to like iterate over all of them. In for a tuple, there's also both, so we could use that as well. So basically, this is saying go over all the entries in the tuple, traverse all of the maps, and then pull out the key value pairs. And that's what this is doing. So nice, easy. F H I. That's not what goes next. It's funny how many times I do that incorrectly. Okay, so we got this thing, this thing. Okay, so this is like underscore with a first. This to come out. Oops. Okay, so we have a map. 2020 Unity Twitch emote. Interesting. I've not seen this one before. Kind of cool. So you just got that unlocked? I thought they unlocked like emotes from my channel. Not that you would want emotes from my channel. That emote's cooler than mine, but it is what it is. Okay, so this is going to give us keys and values for each of these things. And we want to end up with just those, but the keys of the first. So I think that this is just like that. Okay. A, true, B, false. Yeah, nice. If we used dot there, we would get 0, true, 1, false, I think. Actually, we might get 0, 0. Let's find out. Oh, this just doesn't even work. Oh, right, because this isn't not an indexed optic. So actually, we can't. That won't even compile because it's not an indexed optic. Very cool. I was actually thinking, yeah, it's kind of interesting that this even compiles. I didn't think about it, but because we're ignoring the index of the non-indexable optic, we can. Pretty cool. Looks like there's a bunch of new people in here. So, hey everyone, how's it going? My name is Barry. If you've never been here, you made that. No, you didn't. No, you didn't. IJK. These are kind of fun actually. They're little puzzles. So like I don't do Advent of Code. Maybe just James. Hey, how's it going? Feel like I haven't seen you in a little while. But maybe being silly. I don't know. Yeah. Doing puzzles. It's very fun though. I like this book a lot. I'm a big fan. I hope that I get a chance to use these like more often. I think I have to kind of force myself. The problem is I don't really want to do it like Jappy Jappy does it. It just seems like stressful when he's doing it. Like he tries to use optics for literally everything. I'm not usually up this time of the day. Oh, you're just off or something. I might stream during the day next week for reference. I'm off all week. So, and again, I want to finish this book this year. That's the goal. Okay, so what do we want to do here? We want to get roses. Junker Dog, do you use HLS LSP with NeoVim nightly? Yes, I do. That's exactly correct. I have my what is it? Editor. I have the NeoVim set up there. Like that's just my. Oh, that's not even the right link, but I think it should still work. You gotta change the name from that to Chiroptical, and it should work. I thought I fixed that, but apparently not. That video's old as well, but that's exactly what I'm doing. Okay. So we need to essentially So we're definitely going to I traversed. So that'll get us to each of the maps. Then we're gonna I traversed again, but we want to combine these. And I think that's it actually. 0 roses, 3. Oh, there's a flip going on here. So how would we oh, we probably need to write a custom operator. So it's going to be like um what can we call it? We'll just call it flipped. Um so we want to copy this. Oh my gosh. Here we go. Okay. So we're going to not end with a string. The first thing is going to be a int. The second thing is going to be a string. And the result is going to be a string with an integer. Wait, that's not what we're flipping, though. We're changing the order. We're not flipping. Sorry. This is not what I want to do right now. I'm being silly. We need like a reversed. I reversed, maybe? Is that a thing? Three. What do we reverse here? Wait, no, there's nothing. I'm being silly. This is the answer. No. I'm confused. Why is this way? Roses, tulips, frogs, goldfish. But why are these backwards? Oh, it's because it's just a map. It chooses the order. I don't get to choose the order of the keys. So the keys are just in that order. I yeah. Um so the reason I thought it looked weird to me is I thought that the roses and tulips would be the other way. Like they would go tulips, roses, goldfish, frogs. But that's not the case because it's ordered however the map chooses how it's ordered. I don't choose the ordering. That's all. I don't think I might be able to choose the ordering. I'm not even sure if you can. But anyway, I'm just being silly. What are we on? L? IJKL? Is that right? Probably. Uh, so with this one, we want to I traverse plus. So we're composing. So this is just I compose. But it's yep. That's probably not a thing you're allowed to do. Um, the other thing is these need to be ints. This is kind of interesting. Um, so what, I mean, what does this do? It seems like we need some kind of like I over, but like that doesn't really make sense, I don't think. Um, we're just adding two integers. Okay, so I traversed gets us a tuple. Is there an IMAP? We haven't learned about IMAP, but um, would that work? Not really. Kinda works. You need like an extra uncurry or something. Maybe that's what needs to be here. I don't know. This is a weird one. Oh, that's fine. Yeah, that's totally fine. I'm just guessing as well, so it can be pretty tricky to get this stuff right. Um, so like, yeah, it's clear that we need to add them together. So if we had like uncurry plus, right, that takes a tuple and adds them together. So I'm wondering if we need to do uh this uncurry, but that's not like we need to put something here, which I think is like I over. And get rid of this maybe. But maybe we don't actually need uncurry with I over. That doesn't make any sense. Um, I really don't know how this one will work. It takes an I to A to B. Yeah, it's not quite I over. Because like we're ignoring, I don't understand this one. I really don't. Um, let's see. Let's comment this one out for now. Let's see if there's something else that we can. Maybe there's like another trick in here. Um, M. Okay. So we just get 1, 2, 3. I suppose these are going to be printed. Yeah. All right. So I traversed. So I is the index, S is the string. No, this is doesn't make any sense either. What do we need to do? What's this type again? Takes the function to combine the indices. Oh, I see it. I see it. Sorry. So I traversed this. Ow. So this gives us both the indices, but then we need to like put compose in there somehow, I feel like. Because this is composing the two indexes. I think I just don't understand how this works. Yeah, I'm super confused. We need to go look at these. I'm very confused. Really? Oh, it's supposed to be like this, I guess. That makes sense. I goofed up. Because it's got to be the infix version. Um, so percent at over indexed over. So this is kind of the same thing, isn't it? So is this actually? I tried that though. That doesn't make sense. Um, I don't even remember this one. I don't even remember I traverse of. This doesn't even compile. Oh, it's not supposed to be a dot. Oh, I think okay. I must have fixed it. I do not remember what this does. I don't even remember what function, if there is an infix one, what it is. So I don't feel bad for not remembering that. This one I feel a little bad about, but I don't feel bad about this one. Oh wait, what? Where's the blank? Oh, I see. They're showing us an example. Oh, okay. So yeah. Anyway, I just didn't scroll far enough. This is one of my classic mistakes, by the way, where I don't scroll far enough, and it like the example is there. So this is like so I guess it's like that. Okay, so filtering by index. Similar to how we use filter to narrow down the focuses of a traversal or fold using a predicate, we can use indices to narrow down the focuses using a predicate on the index of our fold or traversal. Okay, so indices even, I suppose, could do something. Even indices, cool. It's a bit tough to simplify this type down at all, since it doesn't really fit any of the categories of optics we've learned already. This optic depends on the index of the path you compose it with. We don't have a good name for that sort of thing yet. Indices is quite easy to use. You simply give it a predicate to run on the index and only ignore any focuses that don't match. Easy. I think this makes sense to me. N. So give me all the letters A to Z as a string. I traversed indices even. So this will give me every other letter starting with the second one, I suppose. Oh, okay. Starting with the first one. Oh, I guess 0 is considered even. Sorry. 1 is certainly not even. Really backwards. Fine. An O. Has prefixed dark, so we get 94, 97. Great, this makes sense. It's nice to see that we can use these index traversals even with regular toList of, for example. So that's nice. Index works similarly to indices, but ignores any focus that doesn't have the exact index you specify. Nice. Exercises, because I think that seems straightforward enough. Just put a hole here. Exercises, index, filters. Okay, thing. That's a weird formatting for that, but sure. I guess it makes sense. I don't even know what formatter I'm using right now. Just using some formatter, whatever the default one is, I guess. Okay, so we're going to compute the total number of brunches you should do this week. Okay. So we're gonna take exercises. We're going to make them into a list. This week. So I traversed. Um, Actually, we don't even need the indexed part here or here. Dot indexed. What does this give me? Yeah, and then we can just sum. I think that's right. What if we put traversed here, we won't get the indices. So yeah, that's right. Compute the number of reps you need. Exercise day. Sure. Oh, E is going to be some exercises to list of I traversed index Wednesday traversed think that's right. Oops. So Wednesday, yep, 18. Nice. Okay. List of the number of push. Q. You can use IX. But I need IX here. Oh, maybe it's supposed to be 0? Like for Friday, I guess. I think we probably want this time because we want to get that. Um, I traversed, but keep this one. Dot index push-ups. Yeah, that's. I think that's what they're looking for. I'm not exactly sure. Like, if you want Friday to have 0, uh, I guess you could maybe, but that's probably fine. Okay, so given this board, um, generate a list of positions Okay, so R is board to list of. I traverse. I suppose that this is just this. Oh, guess that's right. Set the empty square at 1 0. 1 0. Yep. So let's make sure that's right. Yeah, it's empty. Okay, so it says hint. When using the custom composition operators, you'll often need to introduce parentheses to get the right precedence. Okay. Um, why does that matter? Shouldn't I just be able to do S board? No. Board. I traversed. Combine. I traversed. Index. 1 0. What is it? Set? Integer, integer. Oh. Okay. So it's like maybe we don't even need these. Maybe it's smart enough to figure this out. So we have to combine the two indices as together before we try and find the index. I think this makes like logical sense. So S should give us XXO. Nice. Okay, so get the second column as a list. Try to do it using index instead of indices. Okay, so RST board to list of I traversed. So keep these traversed index 1. Dot easy. Get the third row as a list. Use index instead of indices. Okay. RSTU. Board. Mm, I think we do want these in parentheses again. Is that right? OO dot. Oh, I think I did the second. I think I did T wrong. Is T right? OX dot. Okay, so we actually got the column that time. So we want the row, which means that we just need to keep this. No, that's the column. Wait, what? OO dot is the third. Oh, I'm being silly. And this can just be traversed. T. Yeah. Wait, what? Oh, maybe like that. I was printing U. I don't think these are necessary. X dot dot. Okay, cool. Being silly. Uh, Drew, Merry Christmas and such. Nice. Thank you. You too. How does the how goes the Haskell? Haskell always going well. We're learning about optics right now, which I think I told you yesterday. Just so I get your name right, I think you mentioned it yesterday or Tuesday or Wednesday or whenever it was. How do I pronounce your name? Is it just like Drew, or is it supposed to be one word, Drewbertska? I'm just checking. Doesn't matter. Fair enough. I'm gonna call you Drew then. It's easier for me. Um, yeah. Thanks for joining. I saw you join the Discord, so that's really good. Um, yeah. Hopefully you find some interesting people in there. Um, so yeah, like this right now is we're basically just selecting stuff out of lists of lists and maps of lists and lists of maps of lists and all kinds of weird stuff. It's a very classic, very weird section, but it's pretty fun. I'm not even going to look up the answers to these because it almost doesn't matter as long as I think I'm doing the thing I expect. So we'll just leave that alone. And we'll go grab this board. We need apparently derive foldable. It's very funny to me that it does this, which is fine. Like, it is what it is. Okay. So we don't need these anymore because those don't do anything. Actually, do we even continue using rank n types? There's no for alls. I don't think we need this in here. But we probably need derive foldable, and foldable is probably what gives us our indices. So we want to allow indexing into the grid, but we want to avoid using ints because they may be out of bounds. We don't want the game to crash. Instead, we'll define our own position type. Oh, sure. I see where this is going. Be arriving, show, peak, or hello? Really? That's how you want to format that? Ooh, I like that. Pretty fun, actually. Uh, but I presume that it's going to be sillier to do this, or not sillier, excuse me, easier in the long run. So, what is up with this? Um, and then we'll just move this out and move this up. Is this right? Oh no, it's not. What happened there? That was very weird. Okay, so XOX dot XO dot OX. That was very strange. Copying and pasting. I don't know if that's events itself or like something in the book about how this is ordered. I'm not exactly sure what's going on there. But anyway, so now we'll want some way to access the positions in our grid. Let's start by building an indexed fold, which accesses each board slot with the appropriate positions as an index. Okay. Normally we'd build a custom fold with folding. So to build an indexed fold, we use iFolding. That is a very signature, but okay. The simpler signature tells us simply have to project our focuses from the structure into a foldable container like a list. The difference from folding is that we also provide an index of type I alongside each value. Let's try it out. Slots fold, indexed fold, position, position. Board A is our structure, and our result is an A. Folding, board, sure, this makes sense. Okay, what's going on here? Okay, you can have flexible instances if you would like. Huh? What now? Oh, there's these under here. Um, what is this complaining about? Do I not have enough? 1, 2, 3. Oh no, I don't, because I deleted the other things. Um, so the last two are O, O, X. Whoops. Okay, next thing. Um, so we turn our board into a list. Oh yeah, it's it's a little bit of an art to figure out what's going on with this whole thing most of the time. What is the issue here? So we're gonna get all the positions I as tuples. So I whatever. Why is board in here at all, actually? I feel like we're missing. I'm missing something here. What am I missing? I folding, indexed fold. So this is our structure. Okay, so we take a structure and we turn it into a foldable of our index, which is a tuple, and A. Do we need to make this? What is this? This is a map of any to any, which is obviously not correct, but it's a map. M is a map. I don't understand. Yeah, this is kind of what I expect, but I don't understand the error right now. Let's see if there's anything else here. So expected type PAFA board A, F of board A. So like somehow this is supposed to get a board at the end? How? List of key and value. May so I'm, no. This is the wrong to list. This is I see what's going on. Um, this is from foldable. Import data foldable to list. That's the wrong thing. So to list comes from foldable. I'm just using the wrong type. So it once I saw the type, I realized what was going on. So for any foldable structure, you can take a TA and turn it into a list of A. So that's just my bad. I used the wrong function. Um, I guess it could be made more clear in the book, but it is what it is. Um, I should have realized what it was. It's kind of my fault, I would say. Yeah. I didn't know you could just derive foldable. That's kind of sweet actually. Um all right. So now we want to just like keep going. So UV is going to be our test board indexed to list of slots fold, and we're going to grab all of the indices which the second value is equal to 2. Kind of a long-winded thing to say, but there we go. Excuse me. So what is this getting us? Where the second one is equal to 2, which I think is going to be the column. What do we get? Dot XO? Okay, so it's the row. Okay, so it's columns by rows. Columns by rows. Cool stuff. But what if we want to edit the slots in our board? I'd recommend implementing the indexed type class we learned about earlier so that we can use IX to access particular slots. But I'll show you how to do it by building an index traversal. Can't we just do it like the following? Um, apparently not. I was expecting that we could just use index to pick out a particular index and then set it with another character, but I guess not. Oh wait, what if I use? No, wrong way. silly me. Um, test board at slots fold index 2 dot at set x. Couldn't match type. Sorry, couldn't match expected type position to car with what? Not const. Um, yeah, I'm. This doesn't work though. Contravariant identity. I don't understand why this doesn't work. Indexed, isn't that what I think it is? Dot at tilde. Import control lens. Yep, it's a setter. It's gonna take an I to B function to B and a structure. Didn't we use this before? Confused. That's over. That's not what we want. I'm not sure. I was expecting to be able to do this. Is it the other way? No? I don't know. Whatever. Let's see how we actually do it. Maybe it's close to what we're doing, but it's not quite. Okay, so this particular index traversal will have a bit of boilerplate. Not usually this bad. Unfortunately, there isn't a helper method for building custom traversals. We'll have to do it by hand. Okay. Oh boy, this is awful. And actually, like copying and pasting all of this is going to be miserable. So I'm just going to do it piece by piece. I think these will all be out of order, so let's not even waste our time. I don't want to write all this. Why are these types like this, actually? Oh, these are not on the same line. I told you this is going to be a night. See how this comes in. All right, so let's first move these over, and then let's get these, put them here. This isn't so bad, actually. These P's, put them here. Get all of these. Oops. Almost done. There's probably a better way to do this, but I don't know what it is offhand. And try to format this. Oh, it's unhappy. Put that there, and then should be happy. And then we can format the code and get this monstrosity, but that's okay. It'll probably get. Actually, it'll probably turn into one long line later when we use the Ormolu formatter. Let's just hope it's a little nicer. Um, okay, so what does this really look like in practice? So we have a P, which is a position, and then we basically just build up a applicative um indexed. Okay, so if we get this P, wait, what is this doing? Yeah, this is just a setter, I guess, or like what looks like a setter. So if we use set, it'll just give us a B, but these have to be the same. So I don't know. It's kind of weird looking. But what does this allow us to do? I don't even remember where we were. W. Hey, why does it do that? Board indexed slot traversal. Okay. Does this now mean we can use the slots traversal to set things? Yes, it does. So now we should be able to use at slots traversal index to set x. Okay, okay. So what did we have before? We had um we had a fold. Okay, so it seems that I've just forgotten the precedence. A fold does not allow you to set. So you need a traversal to be able to change that. Okay, so in theory, I mean, I don't really care about this code necessarily. Like, I understand what's going on here. We have like all of the indices we're going to set to O. So it's going to set the column two, or sorry, column two in this case. Neat. We can even write a function to print our board. We pass the coordinates to our printing function. It can easily add new lines in the right spots. It's kind of fun. X I reverse of slots reversal print slot. If anybody has any questions, by the way, like I'm obviously open to questions. Don't if you're confused or whatever, like don't hesitate to ask me. This is kind of a strange thing to be doing. What is this doing? So why do we want list of C here? Not exactly sure. Because C isn't a string, this is a character. Oh, right. Okay, we need to actually do that. So we put stir anything that's not in the third position. Anything in the third position, we'll just add a new line at the end so that we can make this a little nicer. So x. Oh, right. This is print board. So that's cool. Let's take a deeper look at why our implementation uses this weird indexed function. Certain expanded type of index traversal. Okay, I need to actually sit down. Okay, cool. Um, spaceship has landed. What do we want to do now? All right. So we see here that inside of a function handler, inside a function handler. No, I don't. Go away. Man, goodbye. Okay, really? Two of them? Man, goodbye. It's kind of surprising. Man, banning people is fun. Get out of my channel. All right. The indexable constraint basically just means that it's a profunctor, which can be used like a function handler that takes an additional argument I, which is the index. Don't worry about understanding the underlying machinery here. It gets messy quickly. This is where the lens library starts to get a bit less elegant. The important part is that any indexable profunctor can be reduced into a regular function using index. Any indexable profunctor reduced into a regular function using indexed. Okay, so function from A to B given an index can be turned into a function from A to B. I think that's how you read that. And that's why we call indexed on the handler in our slots traversal. That's a crash course on writing. Okay, hard way. You can write an indexed lens using the iLens helper. Unlike the others, it's pretty straightforward. So we take a structure and convert it to an I and an A. And then this is sort of just the regular lensy stuff. That's pretty sweet. So there are many other ways to add indexes to optics. The simplest is indexing. The indexing helper takes a normal optic and simply adds a numeric index alongside its elements. For example, hello text to list of indexing each. Yeah, that makes sense. Just index every thing. An easy one. I should probably write that one down. Hello text. Actually, we're going to do t.pack. Then, oh, and yeah, I don't need these. Okay, so the only reason I'm not doing this is because I need overloaded strings, and I just like turning on overloaded strings is always kind of frustrating when I'm doing stuff in this book. Okay, we can remap or edit the indices indexes of an optic using reindexed. So just convert I to J. Yet another difficult and confusing type signature. This one uses the provided function to map over the indexes of an optic. So we're just think this makes sense. Yeah, I think so. Oh, but I think the point is, um, with text, you actually need indexing each. With a string, I don't even think you need that. So like if we do x, if we just do y, hello, um, I traversed, it should generate us indexes that are this. However, I guess we can't write t dot pack. Yeah. So this just doesn't work with text, which is actually kind of weird, right? Like, why not? I'm not really sure why that doesn't exist. Um, it may be that we just need to import something from data text lens. I think there's like a data text lens. Let's go check. Data text lens. Okay, so it's defined in the lens library. Let's see if this changes if I import data text lens. It does not change. So I'm not exactly sure why that's not defined. Maybe there's a reason that it's not defined that I don't understand immediately. Does that make sense? I'm going to leave this here though, just as an example. And then I think that's fine. It seems to me like you should be able to just use I traversed is basically indexing each for a, a text. So anyway, reindexed. This is kind of a weird Chris. I don't know who. I'm guessing one of these people is Chris. So hi, Chris. Also, Justosophy. Kind of hard to say. Hello. How's it going? Justosophy. The study of just. Oh no, no, it's fine. It's just like it's tricky to say the first time because it's got like a an interesting cadence in the middle of it. Okay. Reindexed is kind of interesting, but it's not completely clear why I would need this. Although I guess this is kind of an interesting thing. So let's just put that there as an example. Oh yeah. Oh no. My first name is actually Barry. Chris is the author of the book. Yeah, yeah. So actually, for reference, there, if anybody else is interested, there's the book. Um, don't use my link though. Go look for Chris Penner's Twitter because I think he has the book on sale for like 2/3 of the price or something. Seems like maybe. Oh, good, nice, very good catch. Yes, that's exactly right. You can't traverse a text unless you go through the fact that it's like a list of string or sorry, a list of characters. Good call. I think you're right. And we can just quickly look at um, this, and we'll see. Well, yeah, yeah. So it's not traversable, right? Which is a kind of functor, or you build traversable on top of functor. I think I can't remember the hierarchy at the moment, but we could easily. Good call though. Okay, where were we? Oh, right. I wanted to write like an indexed thing. Let's use this one because I think it's kind of. Not sure that this is going to be nice. Yeah, thank you. So it's a functor and a foldable gives you traversable. I'm saying it out loud for people watching because they don't see the chat. If they watch, I don't even know. Need to put up videos actually on YouTube. Okay. Anyway, another helper is self index. The self-index helper is another strange object that doesn't really fit into any other categories. It can be injected into a path to set the index of the path to the current value. This is particularly useful when you need context from higher up in the structure to do some edits lower down. It's tough to imagine what this is good for until you come across it in the wild. It turns out to be pretty handy working with JSON objects. We'll see more examples when we get there. Yeah, I could see that. Like, you want to know like what block you're in or whatever for JSON, so you just keep that index. Although I suppose you can use that the keep left index thing. Oh, but then you can't like rewrite keep left index. So that's what this self index thing is for. Yeah, that I think this makes sense. Okay, so exercises. Good. We love exercises. So we're working on custom indexed optics. Write a sensible implementation for the following indexed fold. I'll read your message here in just a second. Fold. Here. Just let me stub this out. Indexed fold bool a. Okay. Presto. Hey, how's it going? I'm from Rust and love having contact with Haskell with your. And I'm from Rust and loved having contact with Haskell with your lives. I don't understand. I'm sorry, but I'm glad you're here for Haskell. We love Haskell, and I hope you enjoy what you're seeing. Oh, and you just followed. Thank you so much. I really appreciate that. I hope to see you around. Do you? Okay, it says you're from Rust, but have you ever touched Haskell before, or are you just sort of interested in it? Justosophy, how long have you been streaming through these books for? Well, like a year and a half, something like that. Basically, since I started streaming, I've kind of been focused on learning books. So we've done uh, Haskell programming from first principles. We've done thinking with types. We've done most of algebra driven design, which is also Sandy's new book. We're almost done with this book. We also did Book of Monads, Elm in Action, and we're also working on algorithm-driven design in Haskell. But I haven't picked that book up in a while, so I kind of went on a kick where I wanted to do something more practical. So there's kind of like two focuses of the channel. There's like the sort of education side, which is what we're doing right now because I really want to finish this book before the end of the year. And then there's kind of like the do something practical side. We were at one point trying to build our own custom overlay for Twitch. So like there's, this thing over here for subscriber and follower goals, and it turns out that it's actually incorrect. Although it looks like they may have fixed it because it seems to be correct now. So it was broken before. Oh, I'm sorry. Okay, that makes sense. No, that's no worries at all. By the way, it's I sort of figured out most of it, um, but I'm glad you're here. There's keep it there. We also have this Discord, by the way. I should probably be better about saying it, but there's a Discord channel too with a bunch of people that stream Haskell or random functional programming. So everyone is welcome to join as long as you're nice, and you can find other streamers doing very similar things. Yeah. And then Justosophy. In my Intro to Haskell, I did the FP course by Tony Morris and Data61. Yeah, I think I have that on my list of things to like check out. I imagine it's probably too simple at this point. And I don't mean that in a bad way. Like if you're just learning FP, it's probably a good course to get started. But I've been doing this for, I don't know, 2 years now. Yeah, I mean like too simple as in I don't know what I would gain from it, but I'm sure that there's useful stuff in there even here. Okay, so anyway, let's keep going. So the goal here is, uh, I'm glad people are distracting me though. That's fantastic. I want to be. That's the goal of streaming, right? Like not to get anything done and to only answer questions in chat. I think that's the goal. Um, yeah. Anything else? Any other like random questions about like I can do all we can talk about interesting things related to the stream as well. That's totally fine. I'm glad a few people are like there's definitely some new names in the chat, which I think is awesome. Um, we've gotten quite a few random followers recently, so that's been cool. Um, Natum, have you looked at Matt Parton's production Haskell? I own that book, and I will probably go through it when it's finished. I told Matt that I would review his book if he wanted to, or if he wanted me to on stream. So if he remembers, then maybe we'll review it for him. So like Sandy just did the algebra driven design book, and we reviewed it on stream for him for free. Like I'm not gonna charge him any money to do that. So if Matt wanted me to go through his book, I would totally do that. I think it would be fun. That's fair. Yeah, like just writing Haskell code versus like doing it at work is very different for sure. And like I think Matt's book is probably going to be like focused on simple Haskell in production, which I think is a good thing. Probably part of the reason why he wrote the book, I would guess. So I think that that will be a really good book to read. I actually just like started my first Haskell job and my first software engineering job through streaming, so I'm doing Haskell in production. So I'm kind of like learning those as I go, but I still think that the book will be useful. Okay. So I kind of forgot where we were. So let me just look at this again. But I think basically what we need to do is we need to make one of these, not a traversal. We want the fold. So let me just grab. Okay. So here we have the index that we're interested in, and then the input structure, and then the focus. Okay. Let me just take these things and we'll just kind of, actually, let me take this whole thing. We'll just paste it down there and look at it side by side. Okay. So, and let me comment this out because it's going to complain. So our, uh, so we're going to use true and false to index a pair. So the goal is that this is going to give us following. And let me put like a this here or whatever. Okay, so we're going to have I folding, and we're going to have a board. So it's going to be like an X and a Y. And then we're going to just return a list of false X, true Y. I think that's like the simplest definition. And then this will become A prime. So typically what I do is I just work through A through Z. It's not a good naming scheme. It's just a scheme that I use because it's easy. Although sometimes I forget the order of lettering, which is insane because I keep doing it over and over and over again. And then we'll put primes on the first ones and underscores on the second ones, like the second set. Just a weird scheme I came up with. So I think that this is probably right. Yeah, that's totally fine. Is there a more interesting way to write that function? There's probably some wild way, but I can't come up with an obvious way. That's clearly the simplest and most useful definition of pair. Um, oh right, yeah. I have not used block arguments very much, but I know what they're for. Like they're just to eliminate that, right? And Yeah. I've not used block arguments as a like just a thing. I actually don't mind the dollar sign, but I see what you're saying. That's kind of funny. Okay. So let's try to write the traversal now. Um, I think I'm gonna write what do we call the other one? Slots traversal, pair traversal. I don't want to call it pair prime. I don't like that personally. Um, it's not a bad name. I just because it doesn't really matter, but I would like to write it like this. I think to keep it consistent. Okay, so now we're done with this. So I don't think we need this anymore, and that's kind of the result there. And then we need to get. I certainly don't want to copy this whole thing, but it's going to be a. So we're going to take a P. What is a P? A pair of positions. So it's just going to be a Boolean there. So we're going to take a B and we're going to take the structure. And then we're going to build up a pair where we index the things out of it. So we can do it in a very similar style. We'll do an applicative style. So we will fmap this on indexed B. What is it? B false X indexed B true Y. I think this should be right. And then we can do something like B prime A B ampersand pair traversal dot index true that C. And that should set the second value or the second part of the pair to C. AC. Nice. Very cool. Very cool. Um, there it is. Okay. We did that. Use reindex to provide an index list traversal which starts at 1 instead of 0. Okay. So 1 indexed. Um, okay. So, like, this would just be I traverse would compile. And then we want to just re-indexed +1 C prime is A D indexed to list of 1 indexed. I think that's it. C prime. Yep. 1, 2, 3, 4. Nice. If you want to challenge, try using self index. Okay, try using self index. Keep both and re-indexed to write a traversal indexed by the distance to the end of the list. Okay. Inverted indexed. That sounds weird, right? Int list A list B, A, B. All right, so we're gonna start with I traversed. Um, then we're going to keep it. Um, okay, so we now have 0, 1, 2, 3, or whatever. Then we want to like reverse the index. Well, how do we do that? This does feel like a challenge, so I suppose that's a good. So what's the self index we need here? The self index is, oh right. So the self index is literally the thing. Why do we need a self index though? This will take. Oh, it doesn't. I assume it doesn't want us to like just pull out the length of the list. I guess that's the point. Um, I don't know. I don't see this one. What is self index going to do for me? So if we keep the self index, I don't understand. I'm just going to look at the answer. I'm not in the mood to be challenged right now, to be completely honest. Okay, so build the following combinators using only compositions of other opposite optics. Okay, so sure. So our structure is a t.text, and we want to pull out characters from it. Isn't this just each in what how did it work? Indexing each? Yeah, we sort of already saw this one. I'm off now. Have a great night. Thank you. Yeah, take it easy. Enjoy the rest of your evening or day or wherever you are. We'll be here for another hour. Unless I finish this chapter. Okay, so I'm almost done with the chapter, so we'll probably be done. Okay, so car chords. Oh yeah, this isn't gonna work. Um, isn't this right? I thought we would just need to combine. Oh, maybe it's like. Okay, so line by line, 0, 1. Okay, so each of them are. We're basically splitting by lines and then uh getting the. Okay, so I think we need like that traverse of function. So how does this work? So we're gonna get an A, which is our structure, and then that gives us. Oh, but we need I. Okay, so we're gonna get an index, an A, and return an FR. Is this right? I'm just really not in the mood. Just want to look at the answer and think about it right now. It's Christmas. I think I'm ready to be done. I did want to catch up on streaming. Like I was supposed to stream yesterday and I didn't, which is part of the reason why I'm even on today. But let's just look at the answers because it's totally fine. I think the other ones are fine, so I'm not concerned. So inverted index. Oh, okay. So we're just. I see. Wait. Okay. So we're using self index to get the the entire list. This makes some sense. So re-indexed I length I wait, why does this work? Can this be I traversed? Does it apparently it doesn't matter? I was kind of expecting it to matter to be honest. So um so not A through Z, let's do D. Otherwise we're gonna get too much stuff. And then inverted index. Okay, cool. So the idea here is that we're using the self index to get the entire list because we have um, the self index will just get us that. So that's kind of an interesting way to get the thing. If we went if we put I traversed on the left and self index, then we wouldn't have the right thing. What we need is a self index for the entire structure. Okay. So does that change the way we think about this one? Uh, I think that it might because we're just going to probably reindex. Oops. Forget indexing already. What does this one do? It's taking another. Yeah, I don't even remember this lined thing. This is just like okay, so we index all the lines element. That's pretty sweet actually. Um so yeah. I don't know why we would use this, but it's very cool. That's not what I wanted to do. We're not quite done yet, I don't think. We're almost done. So those are cool. That's pretty hard, actually. Did we look up the other one that was difficult? I don't remember. We must have. Yeah, it was this one. No, no, not that one. That one was easy. We looked up this one. Okay, so index preserving optics. You probably already realized using keep left, keep right, and keep both all the time can be a bit annoying. By default, indexes are forgotten with every composition of optics. If you want an index to persist to the end, you need to carry it there manually using the composition operators. The lens library provides a way around that in the way of index preserving optics. Index preserving optics are just regular optics which pass through an existing index in the path. As always, this is easiest to explain with an example. Um, this okay, so I traversed. This won't compile. We require an indexed optic since we're using this, but one forgets the index from iTraverse without adding an index of its own. Right. So we can only keep the index from this one. If we had um, the left composition thing, then we could do that, but it wouldn't give us what we want, I guess. However, we can turn the first selector into an index preserving lens. So lone index preserving lens. Oh, so it should just be this probably. And then that. Except the following. So the structure here is a pair. Could not deduce field one. Um, maybe it's supposed to have like int here. Nope. Could be. I mean, I'm willing to try it. Um, so field one TAB STB. Oh, okay. And then I guess we can just do AB here. AB. Wait, no, we can't because those aren't the focuses. Um, let's just leave it alone. Is this what is this a field one? Okay, that's basically it. We're just converting the lens to a index preserving lens. I think this kind of makes sense, I guess. It's a little weird. Um, then we'll just grab this. And this is D prime. This apparently exists already, so we're just gonna call it one, I don't know, IPL, index preserving lens, just to one IPL, just to avoid the thing. A good call, by the way, for the field thing. I don't know. I mean, I guess from the error, it makes sense that that would be like to do this, but it's not always clear to me that that's like it's not always that obvious for sure. That one was probably more straightforward than some of the other errors we've seen. Okay, so that works, which is nice. The previous is equivalent to yeah. I think that makes sense. Okay, so the previous is equivalent to use explicit index passing. This yeah, because it's just 0 1 and whatever, but if we were using like a map or whatever, then that may not be what we really wanted. um hey, live crashy, how's it going? That's I think that's a new name. I don't recognize that name before. How are you? How's Haskell? Do you like Haskell? First time in here? Nice. I'm usually okay with the names. I have a hard time like taking people's screen names and attaching it to their real names, but you know, it is what it is. I'm doing okay. Thank you for asking. We're kind of wrapping up tonight, but I'll probably be back next week to keep working on this book actually. So we're gonna try and finish it before the end of the during the day. Thank you for the follow. Appreciate that. You'll see me online. So for anybody else as well, before I forget, we also have we is like a group of functional programming streamers. So if you like watching things like Haskell, or you're interested in PureScript or Elm, these sorts of languages, or even like more well, not abstract, but more like theorem provy languages, feel free to check out the Discord. There's a bunch of streamers in there who are doing all kinds of interesting stuff. Um, yeah. Okay. So in this case, it's quicker and easier and clearer just to use this one. But if you're exporting lenses for a library, it can be helpful to know about this trick. It can often improve usability and user experience if composing your optics just does the right thing. Easiest way to make an index preserving optic is to write a normal optic and use the appropriate clone index preserving whatever method. And then obviously there's a bit of tricks necessary to get the types to work, which we just figured out thanks to Nadim. Strangely, clone index preserving fold seems to be missing from the library. There's also IP lens combinator for constructing index preserving lenses from scratch. Lenses are the most likely to be index preserving, since folds and traversers are more likely to have their own indexes. Yeah, so chiroptical. If I jump into other people's streams, I often get like chiropractical or just chiropractor, things like that. It's sort of an interesting word, but there's a description underneath the stream about why I use that name. If you're curious, it just comes from some of the work I did during my PhD. Um, yeah, chiropractor. I am a doctor, but not that kind. I like to fix my own back. Okay, anyway, you won't see index preserving optics come up very often, but sometimes they're just what the doctor ordered. Keep them in mind if you're ever designing an optics-based API. Cool. So next week, or not, sorry,